Let's talk a little bit about even and odd functions. It's actually a very simple definition. If I have f of negative x and it equals f of x, that means I have an even function. Whether I put in a positive 2 or a negative 2, I'm going to get the same answer. Well, if I get the same y value, the same answer for positive 2 and negative 2, what I'm saying is I have y-axis symmetry. On the other hand, an odd function means that if I put in the opposite of x, I'm actually going to get the opposite of the original function. So if I put in a negative 2, I'm going to get the opposite of what I would get when I put in a positive 2. That ends up being origin symmetry. And origin symmetry, you might recall, is when the picture looks the exact same when it's rotated 180 degrees. Some people think about that as a double fold, back over one axis and down over the other. Another way to think about this, and I look for ways to kind of help my mind remember, is when I find f of negative x, that's my test. If I get the same, it's even. If I get the same result as the original, that's even. Same and even, those words kind of seem similar to me. If when I put in the negative x, I get the exact opposite of what I started with, then the O's go together and I get an odd function. All right, so let's take a look here. If I can get that closed. Oh my goodness, there we go. So I have some pictures, right? And in these pictures, I have these graphs here. And this first one, if I were to fold along this y-axis, it would line up perfectly. That means it has y-axis symmetry. If it has y-axis symmetry, we say it's even. Okay, so let me demonstrate. So if I have x equals 1 here, I'd get this y value. Well, when I have x equals negative 1, I get the exact same y value. It's exactly the same height. Okay, I have a beautiful circle here. It does have symmetry, but the problem is, remember our rules, it's not a function. If you have a vertical line that touches the graph more than once, it doesn't qualify as a function. All right, last picture. Now this one, if you were to turn that picture upside down, you would recognize that it's exactly the same. Or, as I said, you could flip this one side back over the y-axis and then flip it over the x-axis and everything would align. So it has origin symmetry, which means it's odd. Again, we could kind of take a point. If I took this particular x and I found the y value, it would be a negative y value. But if I took the matching point, the negative x over here, it looks like it would be just about the same y value, but positive. So they're opposite in sign. What if we are not given the picture? We're instead given a formula. Well, then we just apply the rule. So if I have f of x is equal to this function here, and I want to know if it's even, odd, or neither, I put in negative x for each of my x's and simplify. So a negative x to the third power is going to be a negative value, but when I multiply it by the negative 3 in front, I get a positive 3x cubed. And then here we're going to get a minus 7x, and then we still have minus 1. So I want to compare this to the original. It's obviously not the same, so we do not have an even function here. Is it the opposite? And by opposite, we mean exact opposite. Well, it's negative 3x, positive, okay? Positive 7, negative 7, good. But the problem is here we have a negative 1 and it's still a negative 1. So it's kind of opposite, but not completely. So if it's not the exact opposite, it would be neither. That tells me if I were to graph this, it would kind of look like origin symmetry, but it wouldn't line up perfectly. Let's look at another one. What if I have f of x equals this function, 5x to the fourth minus 3x squared plus 6? Same basic first step. Plug in negative x for all my x's, and then we're going to simplify. So if I simplify this one, when you take something, a negative to an even power, you're going to get a positive. So same thing there. So these end up being exactly the same as the original function. Well, if it's exactly the same as the original function term by term, then what we have is y-axis symmetry or an even function. So you can always verify by graphing these. The other thing I'll point out, you can kind of look at the exponents here. The tricky part are these constants. Okay, so a constant term counts as an even exponent because it's x to the 0. So this really does have all even exponents. This first one has an odd exponent, but remember the constant will count as an even exponent. So when you have a mix, it's always going to be a neither. Let me know if you have any questions.